Hello, everyone, and welcome back to Minecraft Agoraphobia. Cheers, Kevin here, and very excited to introduce my two friends to you. So I'm doing something a little weird in this episode. Right off the bat, I am... Well, we'll get to that in a moment. I'm throwing away an episode. I actually recorded one before this, all about just building these two things. This is a robot. It is a robot that is running on a tier 3 computer with a tier 3 CPU, APU, which is a combined CPU and graphics card. And we put a whole bunch of upgrades in it and tried to max it out as much as we could within the limits of complexity. And this is a drone, which required some end stone, which there's a recipe for crafting. But this is Bratenberg and this is Rosie. I got done making that episode and I realized it would have been a very long amount of time of me just sitting here going like, there's too much, I need one more microchip from over here. Where did I put the other thing? And blah, 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 blah. Building a crafting on demand tool is probably something we'll eventually want to do, as well as a, hey, I need these resources on demand type of tool. So figured the easier thing to do would be to just introduce these two to you, because sadly we lost Kodos in a dangerous fight with a cactus. And I figured, hey, if we're going to be building a new robot that's going to be sort of our beta tester for all cool programs, let's try and make this as overpowered as possible. And then we can build, sorry about that, then we can build some lesser robots once we actually have a script kind of perfected and we know, okay, well, it's only going to require these upgrades or whatever. We can create cheaper versions that'll handle just specific tasks. So this is Bratenberg. I don't pick the names. It picks them for me. You can see we've got memory tier 3.5. We've got a tier 3 hard drive, which is a full 4 megabytes. We have an accelerated processing unit, which, as I mentioned, is a graphics card and CPU all rolled into one. It has an inventory container. It has the inventory controller upgrade, so it can modify its equipped tool and move things in and out of chests, etc. And it has an internet card and a wireless network card. There were plenty of other upgrades and stuff that would have been nice to mess around with, but we just don't have, you eventually run into a limit in terms of complexity as far as what you're able to throw into things. So we do, however, have a couple of upgrade slots. And I forget, did I put a disk drive in this thing? I did not. Okay. We have a tier 3 upgrade slot, a tier 2 upgrade slot, and then a tier 2 card slot. So I can go ahead and give this redstone abilities or take them out. We figured that inventory management was going to be something that we would need in pretty much all cases. And yeah, meanwhile, this is our drone. Now, drones are exactly like microcontrollers, except they can fly. They can't equip items. They do have a little bit of storage. Although I think we had to give it the upgrade to give it that little bit of storage. And I have this running a program. Let me show you the program that I wrote for it. It's very fancy. And it is, while true, do computer pull signal. So it's saying, hey, wait for some random input from the computer. I flashed that onto an EEPROM and threw it on here. So this is doing absolutely nothing. I just wanted it to stand up because as soon as it's powered off, well, it falls to the ground just like that. Interestingly enough, you may notice that I'm carrying a scrunch. It's a very fancy tool, very, very sophisticated piece of equipment. Yeah. You actually need this to pick up drones. I think there's some other components. I think there's a version of these relays where you can hit it with a scrunch and enable or disable some sides of it or something like that. I don't know if we'll eventually get into all of that. But to pick up drones, you need to right-click them with the scrunch, because if you right-click them, normally they open that, and if you hit them, let's see if I write. Okay, I don't know. Yeah, okay, fair enough. So yeah, if you right-click it normally, it opens up the inventory. If you right-click it with the scrunch, then you go ahead and pick it up. So these are going to be the two kind of units. Actually, the drone is one that we're just going. This is Rosie, by the way. The drone is one that we're really just going to use to manage the farm, and I believe Rosie has a tier 1 wireless card, which has a range of 16 blocks or something, and the inventory upgrade and the inventory controller upgrade. So Rosie's kind of plan is going to be to come down here, gather seeds, go back up there, plant the seeds, and every so often tell all of these microcontrollers that we installed in the last episode to do their stuff. Okay. enough jibber jabber. Rather than make you sit through a whole episode of me constructing two robots, I figured better yet, let's just skip all that and I'll introduce you to them. And then we're going to actually do some programming, because programming is more fun than going through a bunch of crafting recipes. Not to begrudge the crafting recipes, but particularly when they're not in the recipe book, it's a slow grind. Okay, we have 3 tasks for today. One is I want to add a yield to movement. Now, I've been thinking about this, and we wrote our move script that we can say, hey, move 5 forward and 2 to the left, or turn left and 2 forward and up 3 and whatever. What I want to do is I want to add another command. I want to just say, hey, I can put the character Y in anywhere in that string, and if you see that character Y, then go ahead and execute some general function. Now, one great use case for this would be if we are planting. So without this, what I would have to say, if I'm trying to program my drone, I would have to say, okay, go forward. I'd have to call move and give it F for forward. And then I'd have to say, all right, now go ahead and, robot.use or robot place down, I think is what we'll end up doing. Or drone.place down. I don't know. We'll figure it out. Then I call another move function call and say F and then blah. Whereas instead, what I could just say is, hey, move FY, 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 and then pass as the second argument the function that I want it to call anytime it sees the character Y in that movement string. So that's what I want to get done for the first task. Second task is I want to track our offset during movement. This should be an easy thing for us to do. I just want us to pay attention to, actually, I should say offset and direction that we're facing. Point is, we eventually want to write some actual pathfinding scripts. So I might want to say, hey, robot that's right over here, I want you to go over here to this square, and I don't want to have to tell you what path to take. I just want you to figure it out. But to do that, the robot's going to need to know kind of where it booted up from and where it is relative to that. So then I can say, hey, move 3 up and 3 across, and I don't care how you do it, but it's going to say, I don't know any of that. I have no idea what I've been moving before now, so I have no point of reference. If we track the offsets that we introduce while we move, then that problem goes away. Third thing, and this is the more challenging task, is I want to write a motion capture script. I would like to write something where I go ahead and I come in here and I can just hit a key like F, and it'll go ahead and the robot will move forward immediately, and then it will add F to the screen. And then when I'm done, I can press enter or something, and it'll go ahead and write out like movement.txt or something and say, hey, this is exactly what I happened to move. That way, I don't have to sit here and go ahead and try and estimate, okay, 1, 2, 3, 4, 5. I can go ahead and just do this with the robot. I can say, okay, now move forward, now move forward, now move forward, and then copy the strings that we generate and throw them into more sophisticated programs. So that's going to make my life a little easier. Let's get started on this first task. Okay, now the first thing I'm going to do is I'm going to create a directory called snippets. Ideally, we would like to put a bunch of this stuff into library files. But the only problem with that is that we, when we create those EEPROMs and we flash those, we're flashing a single file. So if we said, hey, just require the movement library and then use it, well, that's not going to work for drones and microcontrollers, which is something we ideally sort of want. So for now, we're going to be copying and pasting these snippets between all these codes because we're using movement in our power station script. We're using the move function. We're also using it in our storage script somewhere. Move, yeah, function, yeah, there it is down there. So not a huge fan of that, but that's okay. Let's go ahead and grab this snippet here, and we will in snippets create a movement. We'll just call it move.lua. That's fine. Move.lua, and oh nope, that's not right. There we go. Okay, paste there. And now let's think about what exactly we are doing. So the idea is that we can call this by saying move 2 up and then 4 forward and left and then 3 down or something like that, right? That's great. So now all that I'd like to do is I would like to make this optionally accept an argument that does Y. So I say, hey, move 2 up, then do something for me, and then move forward 4, and then do something for me again, and then turn left, and then do something, and then move 3 squares down, right? So anytime it finds this Y character, well, then I want it to do a particular thing, and I'll go ahead and pass that function in Actually, I'm kind of curious as to how anonymous functions work in Lua. Probably not like that. Let's look that up. Okay. So yeah, anonymous functions are easy enough. Yeah. Okay. So that's we don't even need these curly braces. Let's see. I'm gonna if let's create a function called noop just for now. Function noop, and this function does nothing. Nothing. And I'm just going to replace all of these with no ops. So this is the lookup table for, hey, what should we call if we see this character? So if you see left, then go ahead and we used to say robot.turnLeft, but in this case, we're going to just make it a no op because I don't want to have to worry about the fact that we don't have that in there. Okay. So then we should just be able to add another one here. Y equals let's call this f, right? We'll just so move can optionally accept a function, and then y equals f. So then if we actually try calling this, we'll say move 2 up and then y. And then we should be able to actually run this. No, not quite. Expected logical. Okay, line 13. Oh, need commas after all of these. There we go. Run it. Attempts to call a nil value field question mark in line 24. Move direction. Oh, right, because we actually didn't give it a function. Cool. You know what? We could actually conditionally make that available. Well, no, I mean, there's no, just don't use y if you don't pass a function. So function like that, and then we'll just say print doing stuff, and then end. So like that. There we go. Okay, it said doing stuff. And then if we go 2 down, and then do stuffs again, and then turn left, and then go forward 5 times or whatever. Cool, it does stuff twice. And then if we say 3y, then it should do stuff 5 times. Okay, that was easy enough. Only thing is to put the robot bits back in here. Except, while we are here, okay, I managed to reload some config or something. Why don't we try and actually extract this robot dependency entirely? Because drones don't use the same API. Let's look that up, actually. Let's look up the drone component and see if there's a way for us to easily kind of toggle back and forth between those. So they share most world interaction methods with the robot API, but we'll have to call drone dot whatever. So this wraps the functionality of the component robot. What we care about is the component robot. Yeah, the API makes it easier, so things like turn left and turn right don't exist in here. They're actually just helper functions that use these lower level ones. Move is here. This is the direction. File directions are front, back, top, and bottom. So instead of saying robot.forward, we could say robot.move, and then whatever the forward direction happens to be. Which I'll have to look those up. That's fine. And the same with back. And we'll have to give it some number. We'll have to swap those out. Up and down, same thing here. And turning, I think, let's look, turn. Yeah, so turn, are we turning clockwise or counterclockwise? So left, actually, we should be able to do this one. So robot.turn, and if we're turning left, that is counterclockwise, so false. And right is going to be robot.turn true. Except now we have a problem, because what we were doing before was we weren't actually calling the functions. We were saying, hey, if somebody tries to do this, this is the function you should call. So we weren't saying the result of calling the function. We were saying, hey, it's this is the function that you should use. But now that we actually have arguments in here, and I think up is 1. I don't remember. Let's just put some fake numbers in here, and I will figure it out. The problem is that these are going to call these functions. What we really want to say is that, hey, if you encounter the character D, then you should call robot.move with this argument. So we need to figure out if Lua has some sort of way to bind things. Yeah, okay. So Stack Overflow says, hey, just create it yourself. So, okay, we can do that. The idea is that we need to... so instead of calling the functions themselves, we're going to say bind... and then we'll replace these with the arguments. So I'm saying I'm going to create a new function by calling this bind function, I'm going to return a new function that is sort of a delayed execution. Okay, so bind, I'll get rid of this here. Yeah, I can put that down there off screen. End. Yeah, and so then bind is going to take, so we're not following this exactly, but that's okay. So bind is going to take, because this bind is explicit to this one example function. So bind is going to take a function and some arguments. I guess we'll take just one argument. I'm sure there's a way to do multiple arguments easily in Lua, but I'm just not going to look it up because I'm lazy. And we are going to return a function that takes no arguments, but that when it's called, it will go ahead and actually, it doesn't even need to do that. It just needs to, it doesn't need to return it. It just needs to call the function with the argument that we initially passed in. So this is a pretty standard functional programming type of thing, but don't worry if it's a little bit confusing. So think about this. We're saying L is going to be something. What are we creating when we call bind? So I'm saying take this function and take this argument and give me an empty function back. Don't call it, just give me that function. Now, if somebody else calls the result of what we've returned here, then we're immediately going to call the original function with the original argument. So this means that we can use it in our table without actually forcing the things here. So cool. Let me go ahead and populate in the correct sides, and then we'll go ahead and test this out. Okay, actually, last thing, yeah, we did refactor this to not rely on the higher order version of robot, so because that wouldn't be something we'd necessarily have access to. But the question is, how do we actually figure out if it's a drone, the same methods are going to exist, but it's going to be drone dot whatever. So yeah, we got to be careful there. Thankfully, there does seem to be a way for us to detect whether or not a robot exists. And then we can also use, if you remember, the way that we had to set up our water script was to do this component proxy, component list modem thing. So this is basically finding the address of the component and then creating a proxy thing around it. It's a little messy, but we're going to go ahead and say, yeah, we'll go ahead and say bot. Local bot is going to equal component.proxy component.list robot. And then we actually have to call that. And that works in the case that component.list robot exists. But if it doesn't, then what we want to do is call component.list drone. So that's something that we should be able to do pretty darn easily. We can actually just say, because if this doesn't exist, then we just get nothing back. Which I did test very quickly. So we'll say or component.list drone. Whoops. And yeah, let me go ahead and join those lines because it looks weird otherwise. So we're going to say the bot is either the robot or the drone. We don't particularly care. And then instead of calling robot, we'll just say bot.move. And we're assuming that those all have the same methods. So cool. There we go. Now we actually have something that in theory should work just fine on robots and on drones. Now over in Minecraft world, there is the convenient fact that, hey, this bot now has a wireless card in it. So we can just go ahead and download stuff directly. Oh, that's so convenient. No going back and forth, throwing things onto floppy disks. I love the universe. Okay, probably is going to be, we'll probably eventually want to set up a server with an internet card and then use the in-game network cards to communicate to the internet through that server at some point. But that's a whole later ball game. Okay, we have this move script downloaded here. Let's go ahead and edit it. No, edit move.lua. And I just want to add something here. Let's say move. Forward and to forward. Wait, no, sorry. Let's see. Yield and then forward and yield and forward and yield. Right? That should work. And all that I want to do is let's have it robot.swing down. I mean, we'll just do that as what we actually want to test. And just to make this, yeah, we've got to actually require, well, I can just put it down here because this is our actual testing. Local robot equals require robot. And so then we get the full proper robot thing. Oops, GG, huh. because I'm sitting here still thinking I'm in Vim. So this should try and swing down and then move forward and swing down and then move forward and swing down if we run it. Let's now we should just be able to run move, and it should. No. Oh, move is right. Okay, so let's rename that script to move test. I don't know. We need to name it move test.lua. Oops. Move test.lua and move test. Go. Perfect. Okay. So assuming that it actually has the tools equipped, we can now incorporate repetitive actions like feeding sheep or planting seeds into very long movement chain commands. So I'm very excited about that. Oh, man. Okay. So yeah, now basically we'll only have to split up our movement things into in cases where they just don't. We need to do something that's not our standard task. So task 1 is done. So task number 2 was to keep a track of our offset whenever we move. Now let's naively start to think about this. We'll say movement offset is going to equal a list of 3 numbers, X, Y, and Z, right? Our coordinates, the change in the coordinates that we've engaged in whenever we do these things. So well, the movement offset is this. And let's also, let's track our movement, let's rotation offset. We'll say that equals 0 to start, and let's say that we'll keep this value positive. So, but we'll count the clockwise turns, right? So if we turn to the right, then rotation offset would be 1, 2, 3, and then we'll loop that back to 0, so that at any point we can figure out how much we've rotated relative to whatever we started at. Sound good? Okay, so how do we go about tracking these things? Well, left and right now become functions that have additional business we need to worry about. In fact, just about all of this has additional business that we need to worry about. So there wasn't much point in having this whole bind thing anyway, because now we need to write custom functions that are going to say, so left is going to say rotation offset equals rotation offset minus 1 mod 4. Is that, I just want to make sure that's valid. Lua, whoops, Lua. Let's see, 5 mod 4. That gives us 1. Perfect. So that's what we want. Actually, I want to make sure that this is not rotation offset. Yeah, let's put parentheses around there to make it clear anyway. So this is going to be a function that does this, and then it needs to go bot turn false. And actually, we only want it to do that if this thing succeeds. Because if it didn't succeed, then we shouldn't be tracking the change in movement, right? So delete that, and then let me do the same for right. Okay, so left and right should now be, in theory, perfect. If they manage to execute their maneuver, then we update our rotational offset by either incrementing it or decrementing it, and then making sure that it wraps around these values. Actually, with module, yeah, it's fine. We don't have to worry. I was wondering, wait, Lua 1 indexing, maybe that's about, no, it's fine. So we'll have either 0, 1, 2, or 3 in those values, and that counts the number of clockwise turns that we would need to make, not that we would need to make, the number of clockwise turns that we have made that different from where we're currently at, where we started off at. So with forward, we don't know which way we're facing, but that's okay. Let's assume that we're facing in the positive X direction, and it'll be up to whoever actually looks at that offset to translate that information for us. Basically, we're going to treat the first part of movement offset as the, I don't know, the forward axis. Relative to where we started from, not an x-axis per se, but the forward axis. So we would say if bot move 3, then movement offset 1, not 0, because this is Lua is a 1-indexed language, equals movement offset 1 plus 1. And then we can go ahead and just expand the rest of these. So back, then if we move in the 2 direction, then subtract our movement offset 1 minus 1. And up, then, we're dealing with movement offset number 2, so the Y aspect. And then, so if we go down, then we subtract 1, right? And this is all good and done. Of course, we need commas after all of these. But actually, if we think about it, it's not quite that simple, because forward and back don't affect the same. they can affect the X. If I move forward, that could be incrementing or decrementing the X coordinate, or incrementing or decrementing the Y coordinate, because it's based on our rotation. With up or down, it's not a problem because we can't rotate that way. But because we can rotate on the horizontal plane, well, we have to do something a little bit different. So what we can do is I'm going to say if bot move 3, then increment current direction, right? That doesn't exist yet, but that's okay. And and we'll say decrement current direction. And, you know, I kind of want to just make these one function. Offset current direction by positive 1. Yeah. And then offset current direction by -1. And then we'll have to figure out what offset current direction actually looks like. So I'm going to jump down here and write this function offset current direction. And this is going to take some value offset, I don't know, I. And now, honestly, all that I'm going to do is I'm going to take our rotation offset value, and I'm just going to say if rotation offset equals 1, then we're facing forward. So all we need to do is modify if rotation offset is 1, then all that we need to do is say movement offset. Then we are actually dealing with our original forward direction. So movement offset 1 equals movement offset 1 plus the I. Otherwise, if we have rotated, sorry, actually, no, it starts off at 0. If it's 0, then we can go ahead and just add or subtract it in the way it normally would. Otherwise, we have turned to the right, which in Minecraft land is the positive Z direction, for the record. Whoops, else if, there we go. Then movement offset Z. Yeah, if we imagine, kind of ignore the back for now, because the back happens to work because we're dealing with a negative number, then we're going to increment the positive Z direction. Cool. And then if we've rotated twice, then it's going to be the same as here, except subtracting. So if we move forward, but we've turned around, then we're actually subtracting 1 in our forward direction at boot up time axis. And otherwise, we are moving in the negative Z direction. And of course, if we, oops, got to change this to a minus. And this does look repetitive and gross, but you know what? It is what it is. It's fine. Okay, so I've questionably tidied this up a little bit. I decided instead of having all these function equals anonymous functions, I just would create this object local perform and then set perform L, perform R, define all these functions like this. And yeah, we're going to go ahead and see how that works in game. It's moving up and over to the sides and up and over to the side and up and over to the side a couple times. Hope it doesn't get up too high. And look at that. Okay, so what it has told us is that it has moved in 5 positive direction in the Z direction from where it started. It is up 5 blocks in the Y direction from where it started, and it has shifted 0 blocks in the X direction from where it started, and it has no rotation from where it started either. Now, this may seem like trivial. Why do we care? I mean, this is just for statistics. No. Given this information, we could, in theory, get the robot back, right? Because we could say, okay, you've got to move down 5 in your Z direction and then 5 back. Sorry, you've got to move 5 over in your Z direction and then down 5 squares. So we could actually sort that out pretty easily. This is going to be critically important when we start to look at some pathfinding. And actually, even though there is a step 3 that we intended to, or task number 3 that we intended to complete, we are going to stop things there because I'm trying to not have all of these videos be pressing towards an hour. Actually, though, I have recorded the rest of this video, and I'm very excited because, a little spoiler, we don't do step 3 at all. We do something way, way, way more nerdy, and in my opinion, at least, way, way, way more cool. So, oh, okay, I managed to break something well. But tune in tomorrow to see that video. I'm very excited for you to see what we do, and I hope you enjoy. Hope you're having a great day, and I will see you soon. Cheers.